So we're continuing with this problem. We've got a lottery winner. We're trying to find the present value of collecting payments to see how it would compare to a lump sum payment. So the monthly rate of the interest, monthly interest rate, you have to take the annual rate 6 and divide it by 12 months. So 6 divided by 12 months means our monthly interest rate is 0.5%. We're looking for a present value. So we take the amount of the monthly payments, 6,000, divided by 1.005, because that's taking that value times and including then the interest that it would earn. So that puts the present value at about 5970.15. So that's going to be our A, 6,000 divided by 1.005. Our interest rate, our common ratio, is 1 over 1.005. And so then our end value, how many times this is going to happen, is 240. That's coming from once a month times 20 years. So our function, we take S of 240. So that's equal to our A, 6,000 divided by 1.005 times 1 minus our rate, 1 over 1.005 to the 240 power, over 1 minus 1 over 1.005. Plugging this into your calculator, this should get you about 837, 484.63. So this value is obviously less than the lump sum. So best to take the lump sum. And if you're getting 6% interest on $1 million, you're in good shape. Let's just put it that way. So an alternative way, we're not going to do this describing part, just recognize an alternative way of writing this formula is like this. Basically, they distribute the A into the numerator is all that's different there. So that's just a different way of writing the formula. Describe how to find the number of terms in a finite geometric series when some of the terms have been replaced by an ellipses. Usually the easiest way, identify the common ratio. And create the missing terms. Again, there's another method, which is in, I believe, the first video of this series, but typically you won't get a large number of terms, so you can just find out what those missing terms are and then count them. When analyzing an annuity, why is it important to determine the annuity's present value or future value? So since annuities require interest, you have to take their value into account before interest if you want their present value, or after interest if you're looking for their future value. So last thing here, just what's the formula for the sum? We take our initial value A, 1 minus the common ratio R to the nth power, however many terms you have, over 1 minus our common ratio R.